say hello to Jonathan, who is with Aspera, an IBM company, and he is going to be talking to us about stream management, endpoint discovery, and configuration. You're all ready to go?
I'm ready when you are.
All right. Questions at the end?
Absolutely.
Okay, save your questions and make them nice and hard. Take it away, Jonathan.
All right, good morning, everybody. I'll try to keep this a little briefer than I planned, just to try to keep everybody on track today.
We have time at the end.
Okay, excellent. You can go your regular. All right, I'm going to go for an hour and a half then. Fantastic. So my name is Jonathan Solomon. I've been with Aspera about 4.5 years. I came out of being a customer and a 20-plus year broadcast engineer background. So I've gone from analog through 4K in the video side and now streaming and IP. If you aren't aware of Aspera, the 30-second elevator pitch is very high-speed file transfer and now data streaming as well. That's not what I'm going to talk about today. There's a second name on here, Mike Flathers. He's our CTO. I left his name on this deck because he pretty much built the deck and I didn't want to take credit for his work, but I'll be the one talking about it. I'm the face, he's the brains. So what are we going to talk about today? We're going to talk about stream management and endpoint discovery. And we're going to go through in these topics, particularly what's the problem and all the way down to how think we've come up with a solution. So the problem today is everything is manual for endpoint management, right? So we're talking encoders, decoders, software encoders, software decoders, processing, anything that takes us, anything from uncompressed video all the way down to HLS- HTML5. Everything that encompasses all of that stuff and in between is considered an endpoint. And managing those endpoints today is very difficult. This deck is geared more towards contribution, where you have cameras at a venue going back to a broadcast center, but I think all of you can probably relate this to something you may be working with, whether it's an internal project or an external project. But everything is manual. Devices don't know about each other. They don't speak to each other. Sometimes even within the same family, they can't find each other. Most people today are doing spreadsheets. When I was not at Aspera prior to here, I had literally a 50-tab Excel sheet of my endpoints. And that was somewhere UDP addresses or multicast addresses, somewhere unicast addresses. It was very, very large. And when we'd reconfigure the devices, we always had to bring them back, right? Because when you get someone on site, you don't know if your VPN is going to be up right away. You want stuff to come up right away, even if the VPN is not and you can't get into it. So everything needs to come back today to be reconfigured for the next event. And that could be bitrate settings, that could be number of inputs, that could be destination and source. And then all these technologies are manually configured. So you need to match rates, you need to match devices, you need to say I'm expecting this rate to go and this rate to come in. It's manual, 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 a lot of processing. One of my desires, my personal desires in my professional life is automation. You shouldn't be doing things manually that can be done automatically. So that's part of what endpoint discovery is about, is automating that process so you can spend that time looking at QC and making sure the product actually is good, not just getting it up online. So what if we could make all of those things go away? What if we could make a deployment management and configuration of reliable streams as easy as simply plugging it in, turning it on, with as close to zero configuration at both ends, both the stream producer and stream consumer sites? We'll talk about some definitions in a minute of what these are. In fact, here we are, definitions of the terms. So I won't read every one of these. You can sort of read them on your own. We've picked these terms based on our experience with customers. Your terms internally may be different, but basically as a stream manager is a UI or a GUI that allows you to manage everything to fulfill that goal. Producers create streams, consumers consume or decode streams. A device is anything on the network. Processor processes the streams, and the broker is an endpoint that is able to manage all those local endpoints and send them back to a master solution. And then, of course, device discovery is the key here. Automatically discover and register devices as they appear on the network. So, architectural goals of a fully automated stream management endpoint solution. It needs to do all of this, right? This is all really important. Firewall friendly, agnostic, decentralized, but most importantly, easy. It's got to be easy. If it's complicated, then there's no difference in doing it manually. It'll probably take you more time. People won't be able to figure out how to do it. They'll just go back to doing it manually. So how do we make it easy, right? And I apologize. My CTO made this. I don't have pretty graphics, so there's a lot of words. And I said, I'm not going to read all the words. You can read them while I'm talking. But the key to this is discovering the devices, figuring out what they are, what they do, being able to rename those devices to something more human readable, but only having to do that once. I get a device in, and I'm going to call it encoder 17, and that device is always encoder 17 no matter where it is. Now you can relabel it, you can give it a better name later on, but you don't have to reconfigure the bit rate and things like that directly on the device. And then the big one is automatically starting and stopping the devices and the transports to move them. We've got acceleration in here, but any sort of transport is possible in this concept. The interesting one here is detect when it's online and offline. In our development and proof of concepts and working with customers, we found this to be the most critical thing, because if you've ever had a device go offline, you don't know if it's the device, if it's the switch, if it's the network, what it is. You just know that you can't get to it. And the ability to see all your devices at an endpoint through a broker or a gateway allows you to see that, oh, all those devices aren't online. So this is not a network, this is not a device issue, it's a network issue. And being able to get more information to the network team as soon as possible. So what did we end up with when we designed this auto-discovery solution? We ended up with a bunch of microservices. And we did that because it allows us to change and manage things as needed in order to best provide services to the customers, what the customers need to be provided. So whatever the customer needs, we can do through microservices. So the first one is stream management, right? So that's the API to talk to the stream tool, whatever's creating that stream, whatever's sending that stream, the transport. We got some WAMP to discover the other stream brokers, device management API, the web application. Obviously, you want a web application so you can manage it through the UI. That's the key part. And the one I like in here is a video processing service. And what that does is it creates thumbnails so you can actually see what's happening local, respectively local to what you're doing. So if you're at a receive site, you'll see what's coming in through thumbnails. So there's no question of what that system is. This is the whole box is a stream broker. So that's something that's going to live, called a gateway, that lives at the at a site, and it's going to connect all the endpoints at that site through Rendezvous to another stream broker at perhaps a broadcast center. So here's an example of that. We've got 4 venues. Think of this as maybe quarterfinals for World Cup soccer, and it's all coming back to a broadcast center in the middle. So all those venues have multiple producers, stream producers, and maybe a couple of stream consumers for return feeds, and they're all coming into the broadcast center. Could be 60, 80 feeds coming in. The broadcast center can see all those venues, can control those venues, and the venues can control themselves. So how easy is it? Well, it's GUI easy. So we'll go through some of the GUI here. We decided the first way to do this was you had to register the site, right? So here's your master location. It's going to keep configuration and knowledge of all the endpoints that are out there and all the gateways that are out there. So you basically configure it by giving it a name. You can determine if the dashboard for this site can be made public. By being made public, we mean with internally to the site. And then the total bandwidth at this location. The reason this is important is because part of auto discovery is not oversubscribing the lines. So when you're doing contribution, when you're doing distribution, you have a fixed amount of bandwidth. It could be 100 meg, it could be 100 gig. But at some point, you may hit that. So by determining ahead of time what the master location available bandwidth is, you can be alerted if you're going to oversubscribe by making another connection. Well, then you register a remote location. So you bring up a second machine, a second broker, a second gateway, and you determine what the IP is, and you set that up to be one of the remote locations for the Los Angeles master in this case. Now you have 2 endpoints. You have your remote, and you have your broadcast center, your master. You want to group your endpoints so you can see where all your endpoints are going in a syncable list. So in this case, we have multiple brokers, which are handling, these are all World Cup stadiums. This World Cup is our example. I'll explain why at the end. So these are all different stadiums for World Cup, and we're putting them into the World Cup group, or at least 3 of these into the World Cup group, so we can manage them as the World Cup system. So once you have all your endpoints on site, you can make a connection between your endpoints. And we're not saying camera 1 is going to the broadcast center. We're simply opening up a connection to create that path. So we've created this through the UI from St. Petersburg to Moscow. It's one way. And now we're adding systems. Now we're adding endpoints. So in this case, we've automatically discovered 4 systems. A Cisco device, a Samsung device, a Haivision device, and a second Haivision device. Now part of the auto discovery is determining what the devices are. We know the Haivisions are clearly encoders or decoders. We're not sure what the Samsung and the Ciscos are at this point, but we know that they're Cisco and Samsungs, and we know their MAC address, and we can find their IP address as well. So we're going to add this Haivision, and we're going to create some streams within that Haivision. And we've discovered that it's putting out 2 streams. This is all automatic. We're just stepping through a UI to build a stream connection between 2 points. So we see a 15 meg stream and a 5 meg stream. And so we take the 15 meg stream, and we build a stream over this connection between the encoder and the decoder in Los Angeles. Now, we haven't gone on to this encoder, we haven't gone on the decoder, we haven't told them where to go. We're simply just doing this all through the UI. So part of good autonomous configuration and autonomous management is having proper user control. So just a quick view, users can be part of groups. Groups are systems that are at endpoints, and endpoints are the origination source. And they have certain permissions for those users. And then a couple more here. I said I'd go a little fast, so I am. This is the more important part, right? So we've built the connection, we've added the endpoints, we've created the users and the groups that can manage those endpoints. Now we can monitor those endpoints. So we created this, is this going to work? Yeah. We created this St. Petersburg to Moscow a couple slides ago. We're sending a 15 meg stream from that Haivision encoder back to a decoder at 15 meg. And we're seeing a thumbnail of what's going on, so we know what that feed is. We've seen how long it's been up, what the bit rate is, and what the bytes transferred are, as well as the type. UDP, RDP, RTMP, RTSP, whatever the source is. There's a drop-down here that also shows you network stats and shows you more video stats, so frame size, frame rate, encoding type, audio types, so on and so forth. So we can monitor this through this simple, this connection from St. Petersburg. If there was more than one stream, you would see tiling of those streams. So in fact, here you have, so in this model, it's the stream we're looking at. In this model, we're looking at St. Petersburg and all the sources and where they're going. So these are all the feeds going from St. Petersburg to Moscow, and this is relative to the Moscow view. So we know they're coming in. And this shows all our connections as well. It's repetitive because we only have one connection, but it does show that we have multiple connections available for multiple streams. And I'll skip that one. Okay, so I sort of blew through it. Maybe well, hopefully I didn't go too fast, but now you have 7 minutes to ask some questions. Do you have any questions?
All right, well, first a round of applause for Jonathan.
Thank you.
Jonathan left a generous amount of time for questions. So give him some. Who's got some questions?
Nope, one behind you.
Oh, where?
So, like, do we have a server-side coding where we can have a primary backup streams simultaneously ingesting to the servers, and maybe we can create a mechanism for primary backup and maybe a tertiary of a video on demand kind of video playing back if both are not running kind of a scenario?
So that's a great question. The concept of primary backup, failover, high availability is one we're trying to address, right? Glitchless or switchless failover is the panacea. This presentation is about auto discovery. I have another one later about streaming technologies. But But the answer to your question is yes. The concept of auto discovery will allow two devices to go to one, or two to two with a primary and backup. The model that I personally feel is best in discussions with customers is good as well, is really a one-to-one. It's typically a one-to-one scenario. You want to handle the switching of a failover in the native protocol it's happening in, right? So in RDP or in UDP or what have you. If you handle it in the transport, there's a possibility of not catching it at the right time and causing a pretty big glitch. That said, it's certainly possible. So today, in most distribution or contribution models, you have a one-to-one, right? You have a primary encoder, a primary decoder, a primary secondary encoder, secondary decoder, and that switch happens post decode, whether it's in the IP or the SDI realm. You can do it further upstream. The UI will support the ability to do 2-to-1 or 2-to-2 or 1-to-2. That all will be there. We believe that's a good use case. And then the UI you're seeing is what we're calling Stream Manager right now. The working title Stream Manager, that will handle the flip if there's a loss of network or video.
Excellent. We've got another one. All right.
Is there a need on the hardware side for auto discovery? I mean, how would the system know what is the encoder? Is there some need that the encoder needs to satisfy for auto discovery?
No. This is actually agnostic to the device. This is network hardware discovery. So it's NMOS. It's based off of NMOS. What we're doing is we're determining, frankly, based on MAC address, who the manufacturer is. Potentially, there is a possibility for a manufacturer to provide a database of what their devices are based on MAC address, since they know that information. So potentially, this could not just say high vision network video. It could say high vision. The model's escaping me now, but a specific model number, right? And you could even go all the way to say how many inputs and outputs it has. That's very possible if the database was provided. But you're also seeing the Cisco up here, which could very well just be the switch it's on. This concept of auto discovery we're showing, particularly for this group, as video, but there's no reason it has to be video. You could conceivably connect two non-video devices on a network using it and manage it that way as well.
Okay. Do we have another? A little time? Very impressed with the level of questions this year. Sometimes Discovery Track attracts people who are very new to video, but you guys are experienced. You know what you're doing. All right, well, if there's no more questions, another round of applause for Jonathan.
Thank you.
Thank you very much.